Okay, so for the first one here, it is already lined up correctly. We have the x's, the y's, the equals, and the constants, which is what we need to apply Cramer's rule. So we're going to go ahead and set up our matrices. Our base matrix is 3, 2, 1, -1. Doing the determinant, we get -3. Actually, I'm going to do a little shortcut here. -3 minus +2 gives us a -5 for that determinant. Set up the X matrix. We'll do its determinant. -11 minus -1 gives me a -10. And we'll set up the Y determinant, or the Y matrix. And we'll do that determinant. -3 minus 22 is a -25. So our values here, x is -10 divided by -5, which is 2. Y is -25 divided by -5, which is 5. So for a two-variable system with these 2x2 matrices where we can very quickly find the determinant, Cramer's rule is very quick to find it. Number 2 is going to work out the same way. We are lined up, x's, y's, equals, and constants. Let's find our base matrix. And its determinant. 2 times -5 is -10, minus 3 times -3 is a -19. Minus a negative is plus a positive, so it's a -1 is our -10 minus a -9 is a -1. So that's our base matrix determinant. Our X matrix.
So, Mr. Hoff,
Yes, sir.
that's a so that's a +9, not a 19, like you said.
Yeah, I said 19, but it's a 9, yes.
Okay, just double check it.
Yep. So for the X matrix, we got 5 and 9, -3 and -5. Do our determinant there. We've got, come on, 5 times -5 is a -25, minus 9 times -3 is a -27. So that's plus a +27, which will be a +2. And for the Y matrix, right values in here. Two times 9 is 18, minus 3 times 5 is 15. That is 3. So our values here are x is 2 divided by -1, or -2. And y is 3 divided by -1, or -3. So our solutions, and we should list our solutions. On the last quiz, a couple of you didn't, and it really slows me down grading if I've got to look all over for y and x. So we should list them as an ordered pair, 2, 5, and of course this would be -2, -3. Because technically that ordered pair is the solution, rather than each of the individual values. So where we left off yesterday was doing 3-variable systems. We did one example. We'll do another example or two today. Then we'll give you some work time because we cut you a little short yesterday. So let's do 2x minus 5y minus z equals 8. 3x plus 2y plus z equals 10. And x minus 3y plus 2z equals 12. So we're going to go ahead and set up our matrices here. Our base matrix. Remember, it's going to be just the x, y, and z coefficients. So for x, I have 2, 3, and 1. For y, I have -5, 2, and -3. And for z, I have -1, 1, and 2. And I'm just using the straight brackets because I know that we're going to have to find the determinant of this anyway. Let's go ahead and we will rewrite our first two columns. So we got the 2, 3, 1 again. And then the -5, 2, -3. Now I'm going to pause there. Is there anybody that's not sure where I got these numbers from? Okay, good. So now we do our down diagonals. Each item in the top row has a down diagonal. So we do 2 times 2 times 2 is 8, plus -5 times 1 times 1 is a -5, plus -1 times 3 times -3 is 9. That gives me 12 is my down diagonal total. Now we do our up diagonals. Going up, we've got 1 times 2 times -1 is a -2, plus -3 times 1 times -2. Sorry, -3 times 1 times +2 is a -6, plus 2 times 3 times -5 is a -30. I believe that's a -38. So that means our determinant is 12 minus a -38. Well, minus a -38 is the same as plus a +38, so that'll be a 50 is our determinant. So the base matrix comes out to 50. Do the X matrix. Remember for the
Mr.
X
Todd,
matrix.
on all those,
Yep, go ahead.
with all those negatives, on adding, you keep the negative, right?
Yep, so remember, use the number line. If you start at 0, you've got a -2, -6, -30. They all build in the same direction.
And then on multiplication or dividing, they go plus, right?
Well, like here, there was only one negative, so the result was negative. Going down this way, there was a -1, a 3, and then a -3. There's two negatives. So that went negative and then back positive again.
Okay, I got it.
Okay. For our X matrix, remember we replaced the X column with our constants. So it's the constants, then the Y's, then the Z's. So this will be 8, 10, and 12. 5, 2, -3, -1, 1, and 2. And we rewrite the first two columns again. 8, 10, and 12. 5, 2, -3. And then we'll start our down diagonals. 8 times 2 times 2 is 32. Plus 5 times 1 times 12 is 60. Plus, well, -1 times 10 is a -10 times -3 is a +30. That adds up to 122. Our up diagonals. Remember, we have an up diagonal for each member of the bottom row. So 12 times 2 is 24, times -1 is a -24. Plus, -3 times 1 is -3, times 8 is another -24. Plus, 2 times 10 is 20, times 5 is 100. So 52. So we go to combine those. We have 122 minus 52. Add those correctly? I think I did. Okay. 122 minus 52 is 70. So our Y matrix. In our Y matrix, remember, we replaced the Y with the constants. We've got our X values here, 2, 3, 1. Constants of 8, 10, and 12. And our Z's of negative 1, 1, and 2. We rewrite the first two columns. 2, 3, 1, 8, 10, 12. And we'll start our down diagonals. So 2 times 10 times 2 is 40, plus 8 times 1 is just 8, plus negative 1 times 3 is negative 3 times 12 is a negative 36. So that makes 48 minus 36 is going to be a 12 for our down diagonal total. Doing our up diagonals. 1 times 10 times negative 1 is a negative 10, plus 12 times 1 times 2 is a 24, plus 2 times 3 times 8 is 48, which is, I believe, a 62 that comes out to be. So we get 12 minus 62 is a negative 50. Is our Y determinant? Oh, I see what went wrong on our X matrix.
Should be 52, shouldn't it?
Nope, that should be 50 or 62. That's correct.
48.
What's that?
24 plus 48 is 62. How about the negative 10?
24 plus 48 is 72.
Up. Yep.
I do have a mistake on our Y matrix, though. When I copied it, I did not put the negative in front of the 5 in my Y column. That should be negative 5, 2, negative 3 in that Y column. So I'll have to redo that determinant. So I'll give you time to get back to that spot in your notes. Erase if you need to, or just cross it off and start over with the X matrix. So recopy the first two columns again, 8, 10, 12, negative 5, 2, and negative 3. That'll make a big difference. And then we'll start our diagonals. 8 times 2 times 2 is still 32. But now it is negative 5 times 1 is negative 5 times 12 is a negative 60. Negative 1 times 10 is negative 10 times 3 is a positive 30. So that is just a 2 is what we get for our down diagonal total. Quite a difference. Now our up diagonal total, 12 times 2 times negative 1 is still a negative 24. Plus negative 3 times 1 times 8 is still a negative 24. Plus, here's the difference. 2 times 10 is 20 times negative 5 is a negative 100. That adds up to a negative 148. So here we get 2 minus a negative 148. Comes out to be 150. Remember, minus a negative is the same as plus a positive. Okay, so now we need to do the Z matrix. Remember, in our Z matrix, it is the Z column that is replaced by the constants. And let's make sure I put the negative on my 5 in my Y column here again. So there's my Z matrix. So I have to rewrite the first two columns again. And we'll do our diagonals. 2 times 2 times 12 is 48, plus negative 5 times 10 times 1 is a negative 50, plus 8 times 3 times negative 3 is a negative 48, giving us a total of negative 50 for our down diagonal total. Going up, 1 times 2 times 8 is 16, plus negative 3 times 10 times 2 is negative 60, plus 12 times 3 is 36, times negative 5 is a negative 108. That adds up to negative 224. So now we have a negative 50. Something seems off there. 60. No, that seems right. Make sure I got all my numbers correctly in there. Yep. Okay, so we got negative 50 minus a negative 224. That is the same as doing plus 224, which is going to give us, oh, what does that come out to be? 174, and yeah, 174. Come on, scroll for me. There we go. Okay, so our values for x, y, and z here. Our base matrix had a determinant of 50. So x is 150 divided by 50, which is 3. Y is negative 50 divided by 50, negative 1. Z, still not sure why that's coming up weird like that. Something just feels off about Z. Let me double check my matrix on Z because something's not coming out correct there. 3, 1, negative 5, 2, 3, 8, 10, 12. 3, 1, negative 5, 2, 3. Okay, well, that's the way it's coming out. Just seems weird. 174 divided by 50 is going to give us 3.48 is Z. That's what we're coming up with. Okay, so we're going to have you guys try one in your notes here. But what I'm going to do, I'm sure you've noticed, I actually write down my x, y, and z values as I'm making the matrices. I'm going to actually leave them there for you so that you know you're doing it correctly as you go. So we've got 3x minus 2y minus z equals 5. 2x plus 3y plus 2z equals also 5. And x minus y minus 2z equals 3. And again, I'm going to leave this up here. The solution is 2, 1, negative 1, just so you can double check yourself as you're making your matrices, getting your determinants. I will give you guys about 5 minutes to make your determinants and determine your values for x, y, and z. Then we'll go over these. I realize some of you aren't done yet, but let's go ahead and go through this. I got a lot of it set up for us, so we can go through it kind of quickly here. And so you can double check your progress. So on the base matrix, I do my down diagonals, and I get a down diagonal total of -20. I do my up diagonals and get an up diagonal total of a -1. So that makes our determinant, -20 minus a -1, which is going to be a -19. That's the determinant of our base matrix, -19. For our X matrix, I already did the down diagonals. I got a down diagonal total of -37. My up diagonals, I did those, and I got an up diagonal total of +1. That gives us the determinant of -37 minus 1, which is going to be a -38. For the Y matrix, I did the down diagonals, got a down diagonal total of a -26. I did my up diagonals, got an up diagonal total of -7. So we have -26 minus a -7. Remember, that's the same as plus a +7. Gives us -19. And for my Z matrix, I still need to do my diagonals. So I've got 3 times 3 times 3 is 27. -2 times 5 times 1 is -10. 5 times 2 times -1 is another -10, which gives me a down diagonal total of 7. My up diagonals, I have 1, 3, 5, which is 15, plus -1 times 3 times 5 is a -15, plus 3 times 2 times 2, which is -12. That adds up to a -12 as my up diagonal total. So my Z determinant is 7 minus a -12. Again, remember that's the same as plus a +12, which is 19. So X is the X determinant, -38 over my base determinant of -19. X is 2. Y is my Y determinant of -19 over my base matrix determinant of -19, which is a +1. And Z is a Z matrix determinant of +19 over my base matrix determinant of -19 is a -1. So the solution, X is 2 and Y is 1 and Z is -1, which is what we started with. Any questions there? I realize these are some long problems. No way to get around that. So, there's a few problems with 3 variables on that worksheet from yesterday. I want you to finish that worksheet from yesterday as our homework for today. Tomorrow, then, we'll move on to our next topic. So I'll let you guys have we got about 12 minutes left. I'll let you have that 12 minutes to get started on those if you want to. I'll be on the network here to answer any questions as they come up. Otherwise,